All right, so this is just a real quick explanation of complex numbers, section 3.2. So the first thing is you have to understand what the square root of negative 1 is, and it's a defined term for us. So the square root of negative 1 is just what we're going to call I from now on. So if you see the square root of a negative, just know negative 1, square root of negative 1, automatically going to turn into I. All right, so what does this mean for us? Well, let's try to simplify some problems. Suppose we have the square root of negative 36. The square root of negative 36, well, using the definition of square root of a negative, what we can do is we can write the square root of negative 1 times the square root of 36, and then understanding that the square root of negative 1 is just I, we can write I, and the square root of 36 is 6, so our answer is going to be 6I. I like to write the I in the back, very similar to variables. We tend to put the variable in the back after the coefficient. So we can think of the 6 as kind of the coefficient or the magnitude of that complex number. The imaginary component of the number. Number 2. All right, so second example, what if you had something that's not a perfect square? Something like, let's say, negative 8 perhaps. Well, we do the same exact thing. We separate it, square root of negative 1 times the square root of 8, but 8 is 4 times 2. Right, so we can simplify it. So then we get, I 2 root 2. Okay. Now for people that are a little confused by that, just know that this right here is this guy, right? This here is this guy, and this here is this guy. I would simplify this answer a little bit differently. I would write 2 square root of 2. Same thing, except I put the I in the back. Moving on, question number 3. Making sure we understand the concept thoroughly. The square root of negative 9, the square root of 9, negative square root of 9. Once again, notice there's no negative in the radical, so there's no I. This is just negative 3. The only time there should be an I is when there's a negative inside the square root, leading us to question number 4, the negative square root of negative 45. All right, so on this one right here, what happens if you have that? Well, this is negative on the outside, and then we have the square root of negative 1 times the square root of 9, because 45 is 9 times 5, and the square root of 5. And this would give us negative I, right, because the negative sign in the front, 3 square root 5. I would rather you write it as negative 3 square root 5I. That's just the standard form of writing those types of numbers. And then let's do one more example, number 5. What if you had something like 2 square root of negative 18? Okay. Now a shortcut you can take, like, oh, there's a negative in the radical, just put an I. Okay, fine. Right. So we're going to write 2 square root of 18, and then just I. And then simplify the 18, so maybe 2 square root 9 square root 2 I, so that we get 2 times 3 square root 2I, and then 2 times 3 is 6, so 6 root 2 I. And that's how I would simplify this thing out. Now, after you understand what the I represents, negative square root of negative 1, we can start looking at using just I. So the idea over here is that while it is equal, it is really a single direction. You never change I into square root of negative 1. You only change square root of negative 1 into I. And this leads us to our next concept, the next idea, and this is that I to the power of 2 is equal to negative 1. This is, once again, just a definition, but it is derived from what I was said earlier. This right here goes in this direction only, once again, right? We only go I squared is equal to negative 1, and if you're not sure why, well, if you take the square root of both sides, square and the square root cancel, and you get I is equal to the square root of negative 1, which is the definition. All right, so I'm going to undo all that, but that's why what I wrote in red is correct. And it is single directional, right? So we're only going to go in that direction. So I squared goes to negative 1. All right, and then we have example problems. So let's take a look at problem number 6. All you got to do is simplify. So 3I times 2 plus 5I. You would distribute, so we multiply there. That would give us 6I. And then we would distribute, and that would give us 15I to the power of 2. All right, but we remember that I squared is negative 1, so that means this, right, is just negative 15. Negative 15, and there's a 6I in the front. So we have 6I minus 15. Now, at this stage, I just want to remind people that a plus bi is the standard way of writing a complex number, a plus bi, and we call this standard form. So you're expected to be writing your answers this way. It's kind of like simplifying fractions. We just expect it to be written this way. Not the best example, but that's the way we write the numbers. Number 7. Suppose I had something like this: 8 minus 3i to the power of 2. The most common mistake people make here is they forget what the power of 2 really means, and it means 8 minus 3i twice. So I'm going to write 8 minus 3i times 8 minus 3i. And then I actually just have to remember how to FOIL. So we go 8 times 8, 64. 8 times negative 3i, negative 24i. And then, 3i times 8, it's another 24, negative 24i. And negative 3i times negative 3i is positive 9i squared. And then we simplify it, right? So we collect like terms. That guy right there, that guy right there. This right here, I think that's I squared. I think we're just going to write negative 9. So now we're going to go negative 9 and 64. Negative 9 and 64 comes out to 55, so we write 55. And then we have negative 24i, which is negative 48i when you combine like terms. And this is how we simplify complex numbers, right? Complex numbers. Moving on. Last topic is, why do we learn the complex numbers? Well, there are some problems, like problem number 8, where you have to solve it, and the answers are not in the real number system. A good example would be x minus 7 squared minus, plus 13 is equal to negative 3. So suppose we had a problem like that, right? This is a not completing the square. This is a square root technique quadratic, right? So we're going to use the square root to solve it, but we want to get the square by itself first. So we subtract the 13 from both sides. This gives us x minus 7 squared is equal to negative 16. Next, we take the square root of both sides to get rid of the square. Now, up until this section, you'd be like, oh, no real answers. Still correct, but now I need you to actually find the complex answers. So the square and the square root cancel, and we get x minus 7 equals positive negative. Negative square root means we're going to get square root of 16 and I. Now we know what the square root of 16 is. That's just 4. So if you want, you can write x minus 7 is equal to positive or negative 4i. And then finally, adding 7 to both sides of the equation, we get x is equal to 7 plus and minus 4i, our two complex answers. If you have any questions, please send me an email. Hope you have a good one.